All right, welcome to this explainer. Today, we're unlocking the secrets behind how massive industrial machines actually manage to operate in perfect harmony. You know, if you've ever looked at a giant manufacturing plant or a sprawling automated farm and wondered how thousands of moving parts act as one single living organism, you are exactly in the right place. We are going to break down the invisible, digital glue that holds modern industry together.
But before we get deep into the technical weeds, ask yourself this. How does a totally chaotic factory floor, filled with entirely different machines, actually coordinate a single, unified action? I mean, think about it. You might have motors built in Germany, sensors from Japan, and robotic arms from the United States, all operating on the exact same assembly line. Left to their own devices, they're just completely isolated pieces of metal and silicone. They don't naturally share a common tongue. So how on earth do we get them to coordinate with split-second precision to build a car or manage an entire city's power grid?
So here is exactly what we're going to cover today. We'll start by defining what PLC protocols actually are, break down their core components and working principles, explore the massive benefits of getting this right, look at some real industrial use cases out in the field, and finally, check out how DEVI Automation Solutions brings it all together.
All right, let's jump right into Section 1. What exactly are PLC protocols?
The crucial point to understand here is that just like humans in a packed, noisy meeting need some strict rules so they aren't all shouting over each other, machines rely on these protocols to act as their ultimate interpreters. A programmable logic controller, or PLC, is basically the industrial brain of a machine. But for that brain to talk to another brain, they need a standardized set of rules. This protocol dictates everything: how fast they talk, what format the data takes, and how they actually verify that a message was received. Without this protocol, it is literally just digital noise. But with it, it's a seamless, instant exchange of vital instructions.
And you can really see the difference here between an old-school isolated factory and a modern, synchronized smart facility. In an isolated setup, machines operate completely blindly. If machine A finishes a part, machine B has no clue it's coming. That causes massive bottlenecks, delays, and just general communication chaos. But in a synchronized factory running on standardized protocols, machines share data instantly. Machine A essentially taps machine B on the shoulder and says, "Hey, I'm sending a part your way," and machine B instantly adjusts its speed to receive it perfectly. It transforms a group of disjointed, clunky tools into a highly intelligent system.
Let's move on to Section 2, Components and Working Principles.
So what's actually driving this communication loop? Well, there are three distinct components to play. First up, we've got sensors. These are literally the eyes and ears of the factory floor. Their main job is just gathering raw data, like temperature, pressure, or movement. Next, we have HMIs, or human-machine interfaces. These are the screens and dashboards that take all that incredibly complex machine data and translate it into a visual format that human operators can actually read and interact with. And finally, SCADA systems. SCADA is kind of like the big picture supervisor, overseeing the entire network of PLCs, recording historical trends, and managing operations across the whole plant. To put this all into perspective, let's track the journey of a single piece of data. Step 1, a physical detection happens. Let's say a sensor notices a tank is running way too hot. Step 2, the protocol jumps in to format that data so it can be transmitted safely and accurately over the network wire. Step 3, the PLC receives and processes that formatted data, checks its program logic, and realizes, uh-oh, this tank is too hot. Finally, Step 4, an action is triggered. The PLC uses the protocol to send a command back down the line to instantly open a cooling valve. All of this is a perfectly choreographed dance happening in milliseconds, thousands of times a second. Which brings us to Section 3, the benefits of communication. By simply getting these machines to speak the exact same language, facilities instantly unlock three absolute game changers. Number 1, increased efficiency. When machines coordinate automatically, downtime basically vanishes and production speeds up. Number 2, enhanced safety. This is huge. If a hazardous condition pops up in one zone, the system can instantly shout an emergency stop command to every piece of connected machinery, stopping accidents before human reflexes could ever even react. And number 3, superior data tracking. Because everything communicates in a standard format, managers get these beautiful real-time dashboards of every single operation. They can optimize workflows based on cold, hard data instead of just guessing.
Let's transition over to Section 4, Real Industrial Use Cases. Take smart agriculture, for instance. We usually picture PLCs strictly inside dingy factories, right? But out in the open fields, PLC communication allows massive farming grids to completely automate irrigation and climate control, totally hands-free.
Soil sensors chat with weather stations and water pumps. Through these established protocols, the system knows exactly when to water crops, exactly how much to use, and when to open greenhouse vents. It saves unbelievable amounts of water and energy while maximizing crop yields. It's brilliant.
And when we talk about the Industrial Internet of Things, or IIoT, these protocols are doing something honestly groundbreaking. They're the invisible bridge actually connecting heavy legacy factory machinery directly to the modern cloud. By bridging that gap, operators can run real-time analytics from anywhere in the world. They can monitor vibration and heat trends over months and perform predictive maintenance, meaning they can fix a gear a week before it actually snaps. That alone saves companies millions of dollars in unexpected downtime.
And that leads us perfectly into our final segment, Section 5, DEVI Automation Solutions.
Because this is exactly where DEVI Automation Solutions steps in as the ultimate implementer. These guys offer a seriously comprehensive lineup of services to make all of this happen. Whether you need foundational industrial automation, PLC programming, or massive SCADA integration, they have you covered. But they also push the boundaries into the future with AI, IoT, smart agriculture, and even home automation and solar solutions. They are an incredibly versatile partner for anyone looking to modernize.
So if you're looking to transform your operations with these exact technologies and stop leaving efficiency on the table, you absolutely need to reach out to them. You can contact their team directly at deviautomationsolutions@gmail.com. Oh, and hey, if you found this explainer helpful for mapping out the wild world of industrial communication, be sure to hit that subscribe button for more deep dives into the tech that literally runs our world. As we wrap up this explainer, I want to leave you with one absolutely critical question. Is your facility speaking the language of the future? We've just seen the raw power of total machine synchronization, where data flows and everything works as one. If your machines aren't communicating efficiently, if they are still operating as isolated islands, how much potential, safety, and profit are you literally just leaving on the factory floor? Think about it. Thanks for hanging out with me for this explainer, and I will catch you in the next one.